Alright guys, it's 11:40 now. I think we can begin. And yesterday you guys learned about the basics of Python, what modern single board computers are, and you saw a security webcam running. And today we are going to start by learning another. Today we are going to start by learning another software which is important to run this your Raspberry Pi, and it is called Linux. So, yeah, let's begin. I hope all of you can see my screen now. Shriksha, can you confirm? Okay, great. So, Linux. And before we start, obviously, some of you are gonna ask what is Linux. I know most of you would already know it, but for some of you who do not, it's an operating system just like Windows or Mac OS, and which is what operating system does is manages all your hardware resources. And obviously, without an OS, a system cannot function. Okay, so why Linux? You would think why Linux? So it's needed for RPi and many modern day SBCs, which is many modern day sport computers. So it is and it is open source, so it's free, unlike the other operating systems out there, especially Windows, which costs about around 10,000 for a single copy. Unlimited possibilities. It has unlimited possibilities. It means that you would think it's a basic language, but it has a lot of power and it can do a lot of things. You might have seen TV shows like Kali Linux, where Mr. Robot, where he uses Kali Linux to hack into servers and stuff. So Linux is very powerful, and once you learn it, it will help you a lot. Wide support. So yeah, it has wide support. It can work on your PC, desktop, computers, and it also works on most of the embedded systems, such as RPi. And it's less prone to viruses and malware. So any kind of virus or malware, it's very less. You know, it's much more secure than Windows or Mac. So you don't need to regularly run your antiviruses and whatnot. And the other thing I would like to talk about is the distributions of Linux. So distributions means different version of the same software, each with its own flavor, so to speak. So version may not be the correct word, but I don't know how you describe it. Let's say for in mobile phones, we have Android 10 is out now. We have different brands like OnePlus, Realme, MI, and all of them have their own version of Android 10. All of them are based on Android 10, but MI uses MIUI, OnePlus uses Oxygen OS, and Realme uses Color OS. So all of them have the different version or the different flavor to the same Android 10. All of them use the base as Android 10, and then they modify the themes or some extra options, and those are exactly what you could say those are distributions of Android 10. So Linux has a lot of distributions, and some of the popular distributions would be Mint, Manjaro, Debian, Ubuntu, Anthagros, Solus, Fedora. You can see there are many, and based on your choice, you can use anyone. If you are, very new to this, you would like to go towards something like GNOME or Ubuntu, which has a GUI interface, that is a graphical user interface. So it would feel more friendly switching from Windows or Mac OS. And if you guys are advanced users or intermediate users, or you're just comfortable with the text-based interface, you would go for something like the Kali Linux, which is heavily based on only the text interface. And yeah, that's about it about Linux. So let's get started. And why you need to learn Linux, because you would think that you had never learned Windows or you had never learned how to use Mac OS, and yet you can use it. but Linux is a little bit different. It's highly based on commands, so there is a bit of a learning curve to it. And now we'll go and look at some regular commands or basic commands that you will need to navigate through Linux and carry out the simple tasks. Okay, guys.
All right, hello. Can you guys hear me? If anyone can confirm.
Yes, sir,
Yeah.
audible.
Yeah.
Yeah, so
Now we'll
now
begin
we'll
with
begin with
using
using
Linux.
Linux.
I hope
I
all of
hope
you
all
can
of you can
see
see
my
my
Linux windows.
windows.
And
And
if you guys
if
are
you guys are
following
following
using the
using the
online
online
tools that I provided,
tools that I provided,
uh,
uh,
if you're using OpenCalc,
if you are using
you'll directly
OpenCalc,
be on into inside a terminal.
you'll
But if you're
directly be
using
into
the
inside a terminal. But if you are using the OnWorks Studio, then you would have to open a terminal with me. And to open a terminal, you just right click and open terminal. And that's it. This is a terminal. This is how it looks like. So we're going to start writing our commands. So if you guys want, you can follow me along. And if you guys want to follow me along with using OnWorks, it will uh, quickly log off if you stop uh, using it. So if you guys really want to, use the commands with me, I would suggest that open this meeting in a phone and use your laptop for writing the commands. So, anyways, let's begin. So the first command is cd command. Sorry, is there an echo? Yeah, so the first command would be cd and desktop. What it does, it moves you to the desktop. It's the current directory. So in Linux, you always want to be in the current directory where you want to work, because all of the commands are made to be used in the current directory. You can use it in the other directory, but it's a little bit more complex. And the first command that we are going to use now is basically, just like Windows, Linux also uses third-party softwares to run, and you know uh, some for extra functionality. So the first command we'll be doing is sudo apt install vim. What sudo is it provides you the administration permissions so that you can install any application on your system. Vim is a very basic text-based editor which works inside the terminal itself. Now, people who are using CoCalc right now, they do not need to install Vim because it's already installed in there. And people who are using OnWorks, they can install Vim right now. So, yeah, you can run sudo apt install Vim. It'll ask you for the password, and you can write for the OnWorks people, you can write 12345 6, and that would be the password. And as soon as you hit enter, it will start. Since I have already have it installed, it closed in like about 5 lines. If you do not have it installed and you're installing it for the first time, it will ask you, do you really want to do this? And you just enter Y and then press enter, and it will install it. It will hardly take you 10 seconds to install it. And once you're installed, so this is how you would install any programs on your Linux based device. Now the next command what we're going to be using is mkdir, which means make directory. And right now I'm on the desktop, so if you could see to the left of me, I only have a folder known as CNS workshop. As soon as I make mkdir vision, you could see that there is a vision folder as well there. And I would like to make another folder which would be, let's say practice. So now we have two folders here, practice folder and a vision folder. Keep in mind that Linux is case sensitive. So if you want to access, let's say, vision, and if I write, say, v small, So it won't let me access. It will tell me that there is no such file or directory. So if I want to get inside Vision, I'll write Vision, and I am inside Vision. Now, once you're inside here, you can press ls. Ls will show you whatever the contents is. Now the folder is empty, so it does nothing. But you can create files with using the touch command. Just like in Windows, we use right click, new folder or new file, anything like that. In Linux, we use touch, and touch is very powerful. You can use it to make files of any extension. For example, let's make a text file. Like maybe let's make trial1.txt. You always have to add your extension there, and as soon as you execute this command, you go ls again, you can see that inside my Vision folder you will see a trial1.txt folder, and we installed Vim previously, so we
Excuse
can
me.
use Vim. Yeah.
Yeah, sorry to disturb, but there are people waiting in the lobby to be let in.
Okay. Yeah, I'll keep letting them in also. What's the use of touch? Okay, touch makes files. Just as like in your Windows, you go right click new file, like any file you want to make, new text file, new word file, or whatever. One second. Okay, so let's continue. So can you help them out if any, or Shiraksha, can you help them out in the chat? If I can't read the chat right now, so if they have any doubt, please mute your mics, guys. Okay, so let's continue. So what touch does is it makes a file. As you can see, I have trial1.txt inside my folder right now. So now I can use Vim. Or see, if you guys did not install Vim, or you could not install Vim because of anything, you could also go inside Vision, and you can see your trial1.txt. You can open it with a normal text editor, and you can use it that way. But for those of you who installed Vim, I would like to demonstrate how Vim works, because Vim is very powerful. This is a text file, but you could edit a Python file, a C++ file, or even Bash files, which are the configuration files of Linux, using Vim. So what we do is just Vim space trial.txt, and it lets me inside the file. Right now, if you type anything, you won't be able to, because it's in only the read-only mode. You press I on your keyboard, and at the bottom of the screen, you can see the text changes to insert. So now you are in the insert mode, and now you can type anything. So this is a blue line. This is a green line. Anything you can type here. And for escape, quitting, you just press escape. Then you press colon and WQ. What WQ does is it saves and quits the file, and just you press enter and you're out. To see that you made the changes,
Arihant,
to see, yeah.
Arihant, sorry to interrupt, but can you maximize the screen? Like try to maximize the window there.
Oh, you want me to make it bigger? Okay.
Yeah. So that everyone can see what's written.
Okay, is it better?
Size is still the same. It's okay then.
अच्छा नहीं नहीं
Try press
Sorry to
Control
interrupt,
Shift plus.
guys. Especially if you're on phone, you can pinch to zoom to see the text more clearly.
Yeah.
I think the text is much bigger now.
Yeah.
Yes, you guys can see this. So now that we have written file inside our trial.txt, you can use cat command, and what it does, it prints out the output of anything inside the terminal. So if I use cat space trial.txt, it will give me the output. So we just wrote this is a blue line and this is a green line, and as you can see, it prints it out. Another command would be the echo command. So what you can use echo for is to add lines inside a text file or any file without entering the file itself. So let's suppose I want to add key, this is another line. So what I do is I write like this, and I write trial.txt. So you see, nothing happens right now. It doesn't show anything. But if you run, okay, so another thing, you can use the up arrow to run the previous commands. So I can run cat trial.txt, and as you can see, it's added inside the file. This is another line. So this is how you can add. Another command would be the grep command. What it does is it lets you search inside a file for whatever word you want to. Let's suppose I wrote green in the lines 2. So I write grep space green space trial1.txt, and that would return me. Uh, Sorry. Okay.
You have to put green in single quotes, right? Or double quotes.
No, I don't think so.
Trial.txt.
Oh, sorry, it's trial.txt. It's not trial1. My bad. So yeah, grep space green space trial.txt, and it will return you the line, exactly the line you want to use. So if there are multiple lines containing the same word, it will return all the lines. Okay, so I think these are some of the basic commands, and what else you can use? Yeah, there is the CP command. So CP uses can copy files. You would think why would use a command to copy files, but it's more easy. Also, sometimes files are hidden inside Linux, so you can still use your CP command to copy the file. So like this is CP space trial.txt, and then okay, another command would be the pwd command. So once you enter pwd, it will show you what path you are in. So right now I am in home area and desktop vision. This is for my computer. For whatever computer you need, it will show you your path. So if I want to copy this, let's say it's this trial.txt, inside the other folder we made, which was practice, I'll write cp space trial space home area desktop, and instead of vision I'll write practice. So as you can see, it does not return any output. But if I first of all, we need to go inside practice. So you can write cd space dot dot to go up one directory. So you'll return back to your desktop, and then you can go cd practice, so that you're inside your practice directory. And now if I go ls to see whatever files inside here, you can see that I have the file trial.txt here. And just to make sure, you can go cat trial.txt, and you'll see that it's the same file. So it got copied from vision folder to practice folder. You can use the mv command to move files. It's similar to the syntax of the cp command. You can write mv space file name space the directory. So I think you can use that. Other commands I would like to show you, but before that I'll move into my folder which I made is cd workshop. So as you can see, inside my workshop folder I have a lot of files. Another command is that before I show you the command, I'll show you this key inside my workshop. I have two data1, which has a lot of text, as you can see in here, and data2, which has a lot of text as well. But in the end I added this is a different line. So a lot of times what programmers do is that they try to write a code, but some of their code one of their code works, and some of their peers code does not work. So they try to find out what's the difference between them. You can do that manually, but Linux gives you an option, and it's diff space, let's say data1.txt space data2.txt. And what it does, it will show you this is a different line. So the exact line it will match line by line both of the text files or whatever files you give it, and whatever difference it finds, it prints it out, and it gives you 12c2,14. So it tells you like what line your difference is present in. All right, guys. So I think these are some of the basic commands. There are a lot of more commands I think I included in the document, and you guys can try it out. I guess you guys have a feel now how to use the commands. Another thing, we talked about sockets yesterday. So let's just try and run another code with sockets. Idle is a IDE that you can use. And why we are focusing so much on sockets is because a lot of times when you work with your IoT devices or especially Raspberry Pi, you will try to connect your Raspberry Pi to your laptop or your desktop. And socket is a great way to do that. So it can directly connect Python programs. So inside here I have, right now here I have two different programs known as client and server. So the server is a server which will set up on inside your archive possibly, and the client is your client file which will be inside your laptop or desktop wherever you want to send the data from. So this can help you out when you want to send data to your archive to perform certain tasks or something. And I guess you would understand a lot of this code already, but let's just go through it again. So the client, first let's talk about the client part. You import the socket, you create a socket class, you write the host name. For me it's Arihant Inspiron 5570, but for you it could be anything else. You can get to know the host name by using socket.get hostname inside your client, sorry, server file, because you want to connect to the server file. So you will need to know its host name and you need to enter it here. You can connect, you can choose any port, but the lower level number of ports are used by some other applications. So I would suggest using a higher number. In my case, I'm using 8000. Then you can use s dot sorry.
Please maximize the window.
Never, I guess you can pinch to zoom to see the thing. Increasing the font size is going to be troublesome right now. Okay, so
And they are asking where in this code.
sorry.
They are asking you where have you written this code.
Oh, it's inside a Python file. I have already saved it inside my computer. Uh, as you can see, it's known as socket.client.py. This code is not inside the document because like you don't need to know this. I'm just showing you how it works. Uh, so what we'll do is okay, I think I did not explain it fully. So s.connect is used to connect to the server. So you need to provide the host name and the port where you want to connect, and then you can connect to the server. And you can just run a loop so that for the entirety of the loop, the connection stays. And as you can see, you use the send command to send anything, you use the recv, that receive command, to receive anything, and you can print it out. Here again, the same thing. You create a socket, you create a port, max connections. You get the host name here. It's not compulsory, but you get it so that you can put it in here, and then you bind it. So binding it with just the quotations means you will bind it to the host name. That is the default local host name. If you want to use it with external connections or different computers, you would need to put in the IP address here as well, and the port. And max connection, what it does is it tells you how many connections you should make. So we have provided it with 999 because we wanted to keep listening to our server as for as long as I want to. And other than that, yeah, the if okay, so this accept is it will accept any connections that is made to this server. And so inside a loop, you receive the message and you decode it. You need to decode it because it's received in another format, and your computer cannot print that format. It's usually UTF, so you can't print that format, so you need to decode it. All of this is pre-installed inside Python, so you don't need to install any additional libraries. And in the end, you close the connection from both the sides. Send all is used to send replies, so that as you can see here, if I get a hello Python message, I'll reply hey there, or if I get anything else, I'll reply I do not understand. So what we do is we run the server module, and as you can see, it says server started at Arihant Inspiron on port 8000. And now you can run your client module, and you can see the new connection made is popped up here. So now both of the programs are connected. So if I write anything, let's say hello Python, So as we saw in the program, writing hello Python, you will receive from server, hey there. And inside the server, you will receive the message from client, which is hello Python. And if you write anything else, let's say anything else, it will say I do not understand, because that's how we coded it. So this is a simple socket program that's used to transmit data to and back. And we have used this to uh, write programs for today's projects. So that is why I wanted to give you a feel of how these work. And I think that's about it for your intro to Linux. And now we are going to show you the first project we did for today. Is a remote controlled car. One second. Yeah. Meanwhile, we try to uh,
Set up, show you the project. Before that, if you have any doubt about Linux, you guys can ask it in the comment. Okay, guys. So we'll now explain you how we did this joystick project where we made a remote control car using a joystick.
You can see my camera. This is
Rahul, I'm doing the presentation right now, or do you want to show them the live thing?
I'll show the bot first, and then
Okay.
I can move on with the presentation after that.
Okay. So please, guys, I guess all of you can see his camera.
So basically, this is a Raspberry Pi control differential bot. We'll come to the technical details later. So basically, it's a robot car, and here I have the Pi connected to my computer terminal using SSH. So many a times you don't. So we learned yesterday that the Pi is basically a single board computer, right? So you need to give it instructions. So you can either connect a keyboard and monitor to it and give it instructions, or you can connect it using your computer. So it'll send instructions to it via Wi-Fi now. My Pi is connected to the Wi-Fi, so computer is sending it instructions. This is called the SSH terminal. So now, right now, I'm running the code for on the Pi for accepting the commands. So right now, here I'm controlling this robot via joystick. I have take input via joystick. So you see, as I move it forward, it's going forward. It's going reverse. If I like turn left, it will go on turning left. It can turn right. So basically, we will learn now how have we done the wiring inside? What is the code behind this? We'll start this from scratch, and I hope you all understand. And if you all have any doubts, you all can interrupt me in the middle. Yeah. So you can, my data is getting printed on the screen here. Like suppose I turn. I don't think you all can see it that well. See the if as I'm moving the joystick, the coordinates are going on changing. So basically, yeah, that is the project. We'll learn more about the project. This is a perfect beginner's project. So you all just need to know basic Python to code and make this. So let's get started. Yeah, Arihant, can you display the slides?
Yeah, you can begin, Rahul.
Yeah. So as I said in the start, this is a differential wheeled bot using Raspberry Pi. So what do you mean by a differential wheeled robot? So basically, in such cars, you don't have a steering mechanism kind of thing in these robotic cars. So like, how do you turn left and right? So you turn left and right because the motors on the right move faster than the motors on the left. So basically, every different motor on the car can have a different speed. Like in normal cars, the motors on the left and the right have the same speed. But in such type of robotic cars, the motors on the left and right have different speeds so that the cars can turn left or right. When you're turning right, the motor on the right moves faster than the motor on the left, and so the car turns right. So this basically differential. So any bot which is working on this principle is called a differential wheel bot. Now here in this slide, I have the components listed which I have used for the Pi. So our Raspberry Pi requires a 5-volt supply. So for that, I've used the black color power bank on the top, which you all can see. So that feeds a 5-volt supply to the Pi. and I am control. So I have 4 motors here for 4 DC 9-volt motors, and for controlling the speed of the motors and to give them the required input, I have a, you can see the red color PCB, that is called the L298N motor module. So that is basically used to control the speed of the motors and the direction of the motors. And you have a 12-volt battery pack. The blue color battery is a 12-volt battery pack, which is used to give power to the motors. So the 12-volt battery pack is used to power the motors. The 5-volt battery pack is used to power the pi. And next slide. Yeah. Here we have, so basically in this project, it's all about controlling this L298N motor driver. This motor driver controls the speed and the direction of the motors. So how does it do that? Well, down there I have, you all can see there are 6 input black pins down on the lower side. So enable A, input 1, input 2, input 3, input 4, and enable B. Now using this motor driver, this single motor driver module, I can control 2 motors. So I will get 2 output signals basically. On the left, I will get motor A ka output signal, and on the right, I'll get motor B ka output signals. So basically, I can control 2 motor speeds using a single module. So enable A is used to the bottom pin enable A is used to control the speed of motor A on the left. You see the black pins are basically the input pins, and the blue pins are the blue pins on the left and right are output pins. So enable A is used to control the speed of motor A, and enable B is used to control the speed of motor B. Input 1 and input 2 are used to control the direction of the movement of the motor. So say I will give an example afterwards. So say input 1 is higher than input 2, motor A will move in the clockwise direction. If input 2 is higher than input 1, motor A will move in anti-clockwise direction. Now input 3 and input 4 are similar for motor B. So if input 3 is higher than input 4, motor B will move in clockwise direction. If input 4 is higher than input 3, motor B will move in anti-clockwise direction. So that is regarding the input pins. Enable A and enable B pins are used to control the speed of the motor. So I can give any value to it between 0 to 5 volt. Noah Stark has asked a nice question here. There are 4 motors, so there should be 4 motor control pins. But in our project, what we've used a single motor driver. So we have in my project, the motors on the left, 2 motors are connected to the same input pins. So the 2 motors on the left are getting the same speed. The 2 motors, they are both connected in parallel to the same pins. So 2 motors are connected to motor A pin, and 2 motors are connected to the motor B pin. So I'm providing the same speed to the 2 motors. Yeah. And now here, this is basically how the bot looks. So the L298 motor driver and the motors are concealed inside with the wiring so that it looks neat and clean. And the battery pack and the power bank are placed on top. And one interesting thing is that you may see that we have used a 12-volt battery for 9-volt DC motors. We have used this because according to the data sheet, the motor driver has a 3-volt drop across it itself. So suppose we are using 7-volt motors in there, we will have to provide a 10-volt power supply. Suppose we are using, so we have to provide 3-volt more than what the motor actually requires so that it runs at its full speed. Yeah, next slide, Aryan. So this slide basically shows the bot wiring. Here, so the basic concept is that I have programmed certain pins on the RPi to give a certain output, and so basically those output pins I have connected to the input of the motor driver, and based on that, the motor driver is giving a certain output to the motors. Yeah. Next slide. Now we'll go to the code part of this. This is a very interesting part actually. So first, we set the pin mode, which is obvious. We set it to GPIO.BCM in this case. and then we create a class called motor. So the basic objective of my code here is to as I said in the start, this is a differential wheel bot. So if I want to turn right, I have to make the motor on the right move faster than the motor on the left so that it actually turns right. This principle of turning is basically called point turning. If you see army tanks, basically they don't have steering wheels, right? You can't turn them. They have all their wheels are attached to a single belt. So if an army tank also has to turn right, it uses this very same principle. Like the motors in the army tank run at different speeds so that it can turn in a particular way. Now, so in my code, I have tried to emulate the same thing. I have in the start, I have created a class called motor, and I have basically declared all in the first initialization function inside the class. I have basically assigned all the input pins variables. So I may have selected, say, I'm taking random values 2, 8, 7, 13, 14, 15. So I have assigned them to variables enable A, enable B, input 1. So I'm just assigning and I'm setting up whenever you assign a pin, you have to also set it up as output or input. You have to declare if it's an output or input. So I've also declared it as output out here. And I had said that in the enable A and enable B pin, I have to control the speed of the motor, right? So to control the speed of the motor, I have to give a voltage between 0 to 5 volt. So I can give 0 volt if I don't want the motor to move at all, and I can give 5 volt if I want the motor to run at full speed. Now the question is, a pi is a digital device, so it takes in digital input of 5 1s and 0s. So it takes in 5 and 0, and it gives out also 5 1 and 0, 5 volt and 0 volt. So how does an instrument like pi give out an output of 2.5, 3 volts, 2 volts? So it uses a principle of pulse width modulation, so that using 5 volt and 0 volt signals, it gives out outputs of 2.5 volt. So basically, the pi sends out um, signals alternating between 5 volt and 0 volt continuously at such a high speed that it gives an average value of 2.5 volt, and that gets fed. So this is basically pulse width modulation. Yeah. Um, then in the second function, we have it's in the second function we have defined is called the move function. This basically emulates that different motor speed theory I was talking about. So here in this current project, I have used a joystick, right, to take in the input and feed it to the pi. So um, I have used Pygame basically. So Pygame is a Python library, which so the Pygame helps me to interact with the joystick input and give me a corresponding. So if I say turn the joystick up, it'll if I say turn the joystick up, it'll give me a value of +1, like um, +1. And if I turn the joystick down, it'll give me -1. If I turn the joystick right, it'll give me +1 in horizontal direction. If I turn it left, it'll give me -1. So I have used Pygame to get those values, and then those values are fed into this function as speed and turn. You all can see the speed and turn. So speed is basically the vertical axis movement, and turn is basically the horizontal axis movement. So speed is, suppose I move the joystick up in the vertical direction, speed will be returned as 1. And suppose I move and turn will be 0. Suppose I move the joystick in the horizontal direction, speed will be 0 and turn will be 1. So it's basically the y-axis and x-axis kind of theory. So whatever value of speed I get between 1 to -1, I will multiply that by 100 so that it varies from 100 to -100. And have the left speed as the speed subtracted by the turn. So basically, if the turn is positive, the left speed will be um, less and the right speed will be more. So the bot will turn towards the right, because right speed is speed plus turn. So right speed will be more, left speed will be speed minus turn, less. So the bot will turn towards the right. So that's basically the logic of the code here. Then we have, yeah, you can move down. Then we see that at the top of the code, we see if left speed greater than 0, then GPI dot output self dot in. So this is basically this part of the code is basically just saying giving the direction of rotation of the motors. So left speed and right speed variables were used to set the enable A and enable B pins, and these two pins, self dot input 1A and self dot input 2A, refers to those, input 1, input 2, input 3, input 4, those direction controlling input pins I was talking about earlier. So this basically refers to that we are just setting the direction of the motors here. Then there is a function called stop. So the stop function basically changes the PWM to 0. So PWM, like I said, is basically giving any voltage between 0 to 5, 0, 2.25, 2.5 to control the speed of the motor. So when I stop, I want to provide 0 volt so that the motor doesn't move at all. Then reverse is the bot. It's the code from the bot moving in the backward direction. So it's self-explanatory, this part. Reverse is there, and then the move forward part of the code is, see, you all will see that in the reverse part of the code, the self dot input 1 and self dot input 2 are set to low and high respectively, but in the forward, the self dot input 1 and self dot input 2 are reversed. They are set to high and low. So in one case the bot will move in the forward direction, and in the other case the bot will move in the backward direction. So this is that is basically it. Next slide, yeah, Arihan. Here we have the like I said, we are using Pygame to take in input from the Raspberry Pi joystick. So this is the main code which is run. So major part of this code is currently out of our scope because you need to know Pygame very well to understand it properly. So yeah, Arihan, you can move down. So so basically here what is happening is the um, the joystick is taking inputs between 1 to -1, calling that motor class, and the motor class is setting the pins to high and low respectively based on our inputs. So this is the main part of the code. You can see here that based on the inputs, the bot is moving forward, reverse, left, right perfectly. Yeah.
All right, guys. So it may seem a little bit complex, but once you go through the code line by line, it won't be. The only thing the code does is just instructs the certain wheels that you have to go forward, you have to go high now, you have to go low now. Uh, Once you read the code in your own, at your own pace, you will be able to understand it more better. Uh, and I think you guys can do it yourself, especially the bot. It's very entry level. You guys would be don't get disheartened if you don't understand it right now. If you read it on your own time, you will definitely get to understand it. It's just a low and high setting of low and high, but it's a lot of pins and a lot of motor inputs and outputs, so it looks a little bit complex. So now, yeah, that you have seen a basic project, which is a remote control car, we'll move on to the final uh, part of our workshop, which is the AI and IoTs. So what is AI and IoTs? So you guys must know what AI is and what IoTs, though we already discussed yesterday, but AI is nothing but artificial intelligence, such as machine learning. So AI and IoT have a kind of a symbiotic relationship where, so you can say because that IoTs and AI both benefit from each other. So IoTs benefit from AI somehow, and AI benefits from IoTs. So we'll see how AI benefits from IoTs first. So you can know IoT devices generate vast amount of data that might be about an engine's temperature or whether a dopiness goes, weather reading, smart meter. Yesterday I told you guys that it can help manufacturers. So if you are, say in a smart fridge, you have a lot of sensors. it can send back the information to the manufacturer and it can tell it that it's cooling efficiently or it's not cooling efficiently or it's using a lot of electricity, so that he can understand the problems and analyze it so that they can develop a better future product in the future. And there is another example for this, and it's a very big one. So Google has put AI in charge of its data center cooling system. So what Google does is, instead of manually setting up the temperature, just like in our room we have a air conditioner, their data centers also have a cooling system, so that all of the equipments or the machines inside they stay at the optimum temperature so that they function. But before, in past times, you used to set it up manually, and now Google has put it AI in there. So there are thousands of temperature sensors from which it collects data. It analyzes it using artificial intelligence, and what it does is, based on that data, it sets the temperature. So how is it better? So when it automatically detects if the machines are cool enough, it will reduce the cooling effect. So it will save your electricity. And at the same time, it will ensure that none of the devices ever get, you know, malfunctioning or anything. So none of them heat up or anything. And now that we have seen how AI benefits from IoTs, it's time to look at how AI are making IoTs smarter. So AIs can make IoTs even smarter, because they can learn from our behavior and improve. So suppose we have a smart home in these days where you have a smart light, a smart coffee maker, a smart fan, all of that you can use with a touch of a app or a touch of a button, right? But what AI can do here is AI can learn your behavior and it can help you improve on your IoTs even further. So if suppose you incorporate AI into your smart coffee maker and it knows that you like your coffee every day in the morning, suppose at 8:30 and you wake up at 8. So what it will do is machine learning or artificial intelligence. It will learn from your behavior and it will automatically prepare your coffee so that when you wake up, you don't have to even press the button. You just the coffee will be there. So they can also understand other forms of input and be more accessible. So right now you saw a remote control car, which is a typical form of input such as remotes or keyboards or anything, mouse. These are typical forms of input. But what if we made it more advanced? For example, how cool would it be that the car that we used right now with the joystick we could control with gestures? You would eliminate the use of a controller, and anyone could use it because anyone can use gestures. So right now we're just going to show you a really cool project. I know it's going to be a little out of the scope for the introductory workshop, but the thing is that we wanted to show you guys what you can do if you learn RPIs or IoTs perfectly. And let us show you. Rahul, can you? So what we are going to do is we are going to use the same uh, board, but instead of the joystick, we are going to control it using our gestures now. And that is why we explained you the socket program, because right now Rahul's laptop is going to understand he's going to decode his gestures, and according to that, the socket program will send data to the bot, which will then move forward or backward depending upon the data. So if you run the model, it will open the camera and it will start detecting your gestures. So the open hand is used to stop the bot. And
You can see it, right?
yeah, we can see it. Move on.
Now wait, I'll move
So now he
forward.
has shown a thumbs
See,
up.
you all can wait. You all, the bot just move. Wait, I'll. It's
Nahi.
now it's reversing.
Okay,
And I'll
so
stop it again. 1 minute.
see,
Wait, I can't show them simultaneously. One
no,
minute.
just you use your thumbs up and show the bot to us. We don't. I think everybody also can.
1 minute.
So what it does is we use the movement code, the similar to what we used right now with the joystick, which we explained to you before. Just the input, instead of the joystick or the Pygame module, we are using a gesture module, which is a machine learning or artificial intelligence. Rahul, can you stabilize your camera?
Yeah, 1 minute. I'm just keeping the pie on one surface, means so that it doesn't move, and then I'll just show it to you how it's working.
Okay. So here you guys would be able to see that you can control your bot using gestures.
Yeah, this is better now. Now you can see it.
Yeah, so you guys already know the bot
Now
moves, so we'll just show you that the
now,
tires
now
move.
I'm seeing it. See, it's now it's forward. Now again I paused it. Now
That's
again. It's
uh,
detecting fist.
so yes, the machine learning model still needs a little bit of
It's
accuracy.
detecting fist instead of top.
Try some other commands. So it can detect all of your. It can detect
And now
backward.
it's yeah.
Yeah, it can go. If you go put thumbs down in front of it, it can move back. If you put an open palm of it, it stops. If you go thumbs up, it goes forward. Similarly, if you go left thumb, it goes left, or if you go right thumb, it will go right. Uh, I think so. What is happening here is the code is being. Yeah, it's fine, Rahul.
Yeah.
So what is happening here is that the gesture is being recognized in Rahul's laptop using a ML model that we have people at Vision helped us design, and then what we are doing is we are sending the data of whatever, let's say it recognizes this as a thumbs up. So we are sending a data saying move forward to the motor using the socket library to the RPI from the laptop to the RPI using the socket library. I hope it's somewhat clear. You guys can see the ML model, but I think it would be out of scope to understand it right now. Sure, I'll show you the code as well. One second. Machine learning is not a part of electronics workshop right now, but of course I will show you. So this is the code for the actual uh, thing. As you can see, whenever it detects down, this is not the final code. We have changed a little bit. This is just detecting anything. So whenever it detects down, what we do is we send the data to the bot to move backwards. Whenever it detects fist, we send the data to move the stop. Whenever it detects left, we just send the data to the bot to move left. And whenever the fist is open, we send the data to stop. So this is the ML part of it, and the movement part of the bot you guys already saw. That it's the same part that we used during uh, the joystick code. And yeah, that's about it for today's workshop. If you guys have any doubts, please feel free to ask. I hope you guys understood how to use Linux. And if you guys want, we could share you the codes with you guys about the socket server and also the joystick bot movement. And I hope you guys enjoyed today's workshop.